seen this thing previously, maybe in physics or some courses, similar one, maybe, right? If you have two vectors, there is vector A, and if there is any other vector B, and there is an angle between them, then generally we use these dot product approach to figure out the angle. Because I say that A dot B is equal to magnitude of A into magnitude of B and then cos of theta, right? So if I know what is the magnitude of A and B, and if I know this side, I will tell you how you can do this side. You can calculate the angle. It's very easy, right? Before we go further, we know that this A dot B is equal to B dot A. So it obeys commutative law, right? If you add any scalar number with it, so it is equivalent to that you multiply scalar with vector A, or then take dot product, or you multiply this scalar with B and then take dot product. So this is very same, the answer will remain the same. And it also obeys the distributive law. So if you add A and B and D and then take dot product with A, it will give you the same answer that if you take dot product of A and B or the dot product of A and B, right? So if you separately take these two dot products and add them, or add these two vectors and then take dot product for the third one, it's the same answer. So it obeys these things. Now, students, I told you that I will tell you how can you figure out this part. This is equivalent to something, right? What is it equivalent to? Now we are looking into that. When you take A dot B, this A dot B is generally equal to if you multiply with each other these numbers, right? And there is a formula for that. So now think of, I am analyzing this part now. What is vector A? Vector A looks like this, right? If I write the three components, vector A will look like this, right? AX, AY, AZ. Then similarly, if I write vector B will look like this. BX, BY, BZ, right? And I'm taking a dot product. Now, when I multiply them, I will take this, then I will take this, then I will take this. So I will get the three terms, right? Then I will use this, I will use this, I will use this. I will get three more terms, right? And then I will add this one, I will multiply these three. So technically, when I see the total multiplication, there should be 9 different terms, right? 3 from the first one, 3 from the second one, 3 from the last one, right? So these 9 terms will look like this. These are the 9 terms, if you see, right? AX will get multiplied by BX, so I can write them together. And then vector I is getting dot product with vector I. So I am writing them like this, I dot I, because they are vector, right? AX and BX is just the magnitude. So AX, BX is just like a magnitude, like a number, numerical value. And it is the vector, unit vector that is multiplied, I dot I. Here, I dot j will stay in the second term, because I first multiplied like this, then like this, then like this, right? Third one will stay like this, I dot k. Okay? Now, students, we know that when there are two vectors, A and B, I write the magnitude of A, I write the magnitude of B, and then the angle between them, cos theta, right? So if I say instead of A, I have I and I have J. What's their magnitude? Like instead of A, if I say A is I and B is J, then I need to write the magnitude as well, right? Unit vectors have a magnitude of 1. So I will say I's magnitude is 1, J magnitude is 1, and what is the angle between them? Angle is like this. X-axis is here with I unit vector, Y is here with J unit vector. What is the angle? 90. What is cos 90?
1.
Cos 90, just check. You have
Almost 0.
So check.
0.
0, right? So wherever the angle is 90, what would happen? is going to be 0, right? All of these, this will be 0 because when I put the numbers, when I evaluate this thing, it's going to be 0, right? So wherever the angle is 90, either it's like I, J, and K. So this angle is also 90, this angle is also 90, this angle is also 90. Wherever I have a different numbers, like I and J, it will become
JK.
but where I have the same, I dot I, this is cos 0. Cos 0 is 1. Right? So when I plug this value, this will become 1. When I plug this value, it will become 1. When I plug this value, it will become 1. Rest becomes 0. 6 of the terms, they will become 0. Only this will stay, ax, bx will stay, ay, by will stay, and this will stay. Right? So a dot b is equal to this term. Remember this thing. And this is a scalar term. This will end up with only numerical unit, right? Because we don't see anything else besides this, right? There is no unit vector in this. So this is the idea that if I know the magnitude, and from this side, what I do, I just simply do this thing: ax bx plus ay by plus az bz. If I solve this term and get a value here, I can calculate the unknown angle between the two vectors. Right? This is what you do generally if you are going to solve something like this. This is just the equality that again you take cos on the other side and then you can calculate the values. The same thing, but I have just told you here, right? That you can calculate cos theta from here if you use this side and then you divide this thing by a magnitude and b magnitude. This will be equal to cos theta, right? So it's the same thing that is mentioned here. Now, students, one very important thing, and sometimes it's very useful for the numericals, right? Think of that there is a vector A like this, and there is any line, any axis, A axis, B axis is passing like this, right? And think that for this axis, you know the unit vector somehow, like maybe using positions, maybe using something else, you know what is the unit vector involved, right? So if you take so there is a unit vector I said. There is a unit vector, vector A. There is a axis going like this, and you know the unit vector for this one. The angle between them is theta. If you use the dot product for these two, right? If you take the dot product for these two, it would look like A dot UA is equal to the magnitude of A, the magnitude of a unit vector, and cos theta, right? It will look like this. Once you put the definition, this is how it will look. The vector A, then instead of B, you have the unit vector, right? Then magnitude of A, magnitude of unit vector. Unit vector, you know that magnitude is 1. So you can replace this by 1, right? So magnitude, unit vector for this one can be written like this: magnitude of A and cos theta, right? Something like this. You can solve it like this. Now, A cos theta, if you see, what is this A cos theta? A cos theta, now I'm talking about very important thing, students. That what this A cos theta represents. A cos theta, what about if you solve it like a triangle? Now think of that this A vector is like this, right? You take projection like this one, and you take this vector, like you're talking about components. So this component is A time cos theta. this component is A times sine theta, right? The one you get here is technically this magnitude. The one you are getting here when you do the dot product, right? This is the answer of a dot product, right? This is the same when you do the projection for the vector, right? Now again, think very carefully what I'm saying. If you know the vector A, if you know the unit vector, I can calculate what is the projection. What is this vector which is highlighted, right? Again, two things. Like this is a tricky concept, but you will see that it will be used a lot in the problem solving. When I know a vector, force vector, when I know its axis, unit vector, I can calculate what is the component of force on that side, on that axis, right? So this is what I'm trying to say. If somebody asks you, calculate this projection, what is this vector? Then what you need to know? You need to know the projection of the actual vector A. You need to know the unit vector only, and then you can calculate indirectly that what is this magnitude for this, right? So once you know this thing, then we generally say that this is the component of a vector. We call this side, the one which is here. This is the vector, this is the projection of a vector parallel to A, like parallel to A axis, right? What is this? This is projection of a vector which is perpendicular to A, right? So sometimes the question gives you something like this, that this is the direction. They tell you that this is the force. You calculate the projection that is parallel to this side and which is perpendicular to that side, right? So once you know this parallel one, once you know this one, by using the Pythagoras theorem, which is here, you can calculate or normally use the addition of vectors or subtraction of vectors. You know that if this is vector A, I can use using head to tail rule, I can write it like this. A is equal to A which is parallel to A plus A which is perpendicular to A. I can write it like this, right? So if I know this one, if I know this one, I can subtract them and I can figure out what is the perpendicular component. Right? So this is just head to tail rule, how you add vectors. So it's mentioned here. And I can also use Pythagoras theorem to figure out the value for this one. If I know this is 200, if I know this is 100, I can use Pythagoras theorem and I know how much is this, the value itself. So I can calculate the vector by using this, and I can also calculate the magnitude by using Pythagoras theorem like this, right? Make sense to you or no? Should I explain it again? Is it fine? So just remember this thing that if I know any direction like this, and there is any vector like this one A, I can calculate that what is its projection in this direction by taking this simply the dot product, right? I take this value, and if I know somehow what is the unit vector, I will just simply take the dot product of these two, and this will tell me how much is this one, right? But scalar, magnitude. Because dot product is not, the final answer is only the numerical value. So it will tell you the magnitude of this, right? So for example, it will tell you that the magnitude is 200 for this. You already know the unit vector, so you can use them together and you can build vector, right? Now I'll show you the way how it can be used, for example. So students, in this case, the question is asking you that think of this frame that is shown and this is subjected to a horizontal force, as you can see here. Determine the magnitude of the components of this force parallel and perpendicular to the member A and B. Okay. Here they have given you this force and they have told you that this is only in y-axis. So there is only J, right? This force is like, you can say that 0I plus 300J plus 0K, which means it's only acting in which direction?
Y.
Only in y direction, right? Now they have given you, they are asking you that if you extend this line A and B, this is A and B direction, and this force is like this, what would be the projection of this force in this line? Like what would be this force? Right? Force projection, projection of the force parallel to line A and B. They are asking you this. Right? And then what is perpendicular to it? What is the projection that is perpendicular to A and B? So if I want to know, if I know the dot product, to calculate this, what do I need? What two things I need to take the dot product? Force is already there. I know the force vector. What else I need? The unit vector, right? So think it off like this. Think it off that if this is axis, like I'm calling this axis A, right? If you know the unit vector of this, and this is already known, the force is already known, when you take dot product, the answer what you get here is what? Is the projection, is the projection, but again the magnitude, not the vector itself. Dot product gives you scalar answer, not the vector answer. Cross product gives you the vector, right? So if I do this thing, I can get the number, let's say 200. So I know that what is this? This is 200, and then I know the unit. So I can use them together, and I know what is the vector itself as well. Right? Because unit vector you already know. So can you help me, students, now? How can I calculate the unit vector in this direction? A is origin. What is B? What are the coordinates in B?
6.
How much x?
6.
X is 2. X is 2.
X is 2, Y is 6.
Y is 6. So x is, this is 2, then 6, and then 3. Right? So if I erase this one, it's like this. So this is 2, 6, 3, right? Formula you can see is the same. So if I know, can I calculate the position vector A to B? What is R A to B? Final minus initial. So it will remain 2I
6J
plus 6J plus 3K, right? And then I need to get the unit vector from here, right?
which is the minus
So first get the magnitude.
7.
Magnitude is under root 2 square plus 6 square plus 3 square is equal to 7. So the unit vector for R, A and B is 2 over 7 plus 6 over 7 plus 3 over 7, K, right? Now I know the unit vector in this direction is this one, right? And I know the force is equal to 0I plus 300J plus 0K. So if I take dot product of these two, this should give me that what is the projection here, right?
Which is I'm calling by 300 times 6 over 7.
Yeah, let's do that. So you know that when I am solving, this is the unit vector A and B, let's say. So how do we solve it? You remember it is AX BX.
Yes.
If you remember the expression, this is the expression. When I have two numbers, the rest 6 of the terms are 0. Only these 3 terms will stay, right? So in this case,
0 times 2 over 7
0 into 2 over 7
plus 300 times 6 over 7 plus 0 times 3 over 7.
6 over 7 plus 0 times 3 over 7. Now this is 0 because multiplied by 0. This is 0, only this will stay. So which is equal to
257.14.
257, let's say. I call it 257, right? Now this is the magnitude. remember that what you got here, if there is a vector, like if I call this a vector, I am calling this vector force projection parallel to A and B, that's right, because this is in the direction of A and B. So you got the magnitude here. Direction you already know. Direction is already there, right? You just simply multiply 257 with this unit vector and you will get the force vector. What you got here is the magnitude, remember this thing, right? So if I say this is a vector, its magnitude is 257, but the unit vector is the same that you already know, R, A and B, right? You just plug the values, just multiply and you got the vector basically, right? So tell me what would be the vector when you multiply? When you multiply 257 with this unit vector,
73.4.
73.4, I
220.2.
220 point, let's leave points, J,
Next one. 110.1.
110K, that's right. So you, in the end, you know this vector, right? This is the vector you have now. You already know this other vector as well. I will highlight it so you can, I know that this is the vector F. Can I calculate what is the perpendicular vector? What is this one? F perpendicular. Which two vectors you need to add to get the third one here? There are three vectors, right? Think here, there is vector 1, this is vector 2, this is vector 3. So vector 1 is like this, vector 2 is like this, vector 3 is like this, right? How the two vectors will add, which two vectors will add? Head to tail move.
1 and 3, but subtraction.
No, 1 and 2. First you will add 2, right? So you will add, for example, 1 plus 2 to get the third one. But you want to figure out this value, this. So you are saying that 2 will be equal to 3 minus 1 vector, right? So this is, in your case, this is the force vector, this is the parallel vector. So force minus this, right? Let me erase this thing a little from here. So it would be, perpendicular would be equal to the force vector F minus F parallel. This is 0I plus 300 K plus 0K minus 17.4I 220K plus 100. So if I show you, it should be minus 73.4I 300, so this would be plus 80, okay, and it would be minus 110, okay, right? This is the perpendicular, F perpendicular. Now let me show you the numbers now related to that. So there is, so this is the fraction one, you don't write fraction, you wrote it 2/7, 6/7, it's the same thing. And then you can see that this is 257, right? The answer with the magnitude. Then we already know the unit vector, this is the 2/7, 6/7, this one. We just simply multiply, we got this vector, which is the parallel vector. And this is F parallel, right? and then you just simply subtracted both. So this is what you got, right? And if you are again supposed to do calculation for magnitude, then you can again either take the magnitude of these one, right? Or you can use Pythagoras theorem. So you know that the Pythagoras theorem for this one is, like we know, this vector is 300 and we know that this vector is 257, right? This is we don't know. So you can use Pythagoras theorem. X is equal to under root 3 square minus 257, right? Just the Pythagoras theorem. To calculate the magnitude, or you have the vector. Like you can use this vector and you can calculate the magnitude with it. Right? If I show, maybe you can do one quick calculation just to double check.
Professor, for this one, we have to keep the minus, right?
Which one?
For the last one.
Here in the Pythagoras?
Yes, here.
Because you know it's like here you're not calculating the magnitude. This is not a magnitude. This is Pythagoras. It's like this, that you have this 300, this side, you have this side 257. And let's say this side you don't know, this is x, right? So you say like this, 300 square hypotenuse is equal to 257 square plus x square. And then you, when you take it on the other